Hi, this is the next video in Numerical Methods. So in the last video I talked to you about how we could locate a root. So if we have an equation that is difficult or impossible to solve in the usual convention, then the first part of the process in trying to solve it with a numerical method is to figure out roughly where it is. So we talked about how to locate a root in a given interval by looking for a sign change. Once you've established that there's a root in a certain interval, then we need a process by which we can actually figure out what the root is. And we've got two options. We've got an iterative formula, which I'm going to show today, and we've got a Newton-Raphson method, which I'm going to show in a different video. In order for you to understand and see how the iterative formula is working, I'm going to actually base it on an equation that we do know how to solve, this quadratic. Okay, and also so you can see that the iterative formula is working, I'm actually going to figure out what the solutions are. So if I pop that quadratic into my calculator, then I will get x equals 4.56 and I will get x equals 0.44 to 2 decimal places. So that is the solution to that quadratic equaling 0. Okay, so we know where they are. Okay, so we're going to pretend that we don't know where they are, but then when we figure out using our iterative formula, we can actually see. Okay, now to find and get an iterative formula, we basically take f of x equals 0 and we rearrange it into an alternative form, x equals g of x. So we're going to set or rearrange it so that we've got x on one side and the rest of the equation in terms of x on the other side. And once we've got it in that formula, then we can just put little subscript notation to make it into an iterative formula. Now you've seen this subscript notation before when we were doing recurrence relations, when we were doing series, and it just means an x value and then the next x value, so it works in exactly the same way. Okay, so to write it in the form x equals g of x, well, we can do this in several ways. There's no hard and fast rule. So for example, I might decide I'm going to move the 5x and the 2 to the other side of the equals. So I'm going to add 5x and take 2 off. And then I might square root it. And I will get that. So that is in the form x equals g of x. I could do something else with it. So I could, if I wanted to, I could add the 5x to both sides, for example. And then I could divide both sides by 5. So that will give me x equals x squared plus 2 over 5. That is also in the form x equals g of x. If I wanted to, I could divide everything, if I wanted to, by x. If we divided everything by x, I would get that. And then I could make that the subject, or that at the start. And that is in the form x equals g of x. So I could do all sorts of things. If I wanted to, I could take out a factor of x there. And then move the 2 over and divide by the x minus 5. That's in the form x equals g of x. Okay, so I can literally do anything as long as I've got x on one side and the rest of it on the other side. And if you think back to the very first slide in the previous video, where I got you to solve 4 equations that led to the same quadratic, all I did to get those 4 quadratics was to start with the quadratic that I wanted and then just rearrange it in 4 different ways. So it's exactly the same thing. Okay, now I've got each of those in the form x equals g of x. To turn it into an iterative formula, I literally just put an n plus 1 and an n plus 1, n on each one. And they could all now be potentially used to solve my quadratic. Okay, so I'm not going to use all of them, but I could literally take any one and one of them will give me one of the solutions. Okay, so I'm going to start, I'll demonstrate. I'm going to actually start with that one there. And then afterwards, I'll use that one and I'll show you what happens if I use that one. So here is my quadratic. There it is. And I'm trying to solve where this equals 0, remember? And here's my iterative formula. And I showed you where that came from on the previous slide. Okay, now we know we have got a solution at 0.44 and we've got a solution at 4.56. Okay, so I'm going to pretend I don't know that, and I just know that, for example, I have a solution in the interval 0 to 1, for example. Okay, so I'm going to basically guess, and the iterative formula is a little bit like when you do sort of, I've thought of a number between 1 and 100, and you might guess 50 and I'll say higher, so then you might guess 75 and I'll say, and eventually you just converge on to the number I've thought of. It's the same sort of process. So I'm going to do an initial guess. So I'm going to say my initial guess, I'm going to say my first guess is a 1, because I know I've got a root close to or between 0 and 1. So I'm going to say, okay, my first guess is a 1. Okay, so this is x1. So if I then do x2, well, x2, now I'm using my iterative formula. The iterative formula is just saying each x value is equal to the square root of 5 times the previous x value, take 2. So that's what it's saying in a sentence. So x2 is equal to the square root of 5 times x1, take 2, which is the square root of 5 times 1 minus 2. So that is the square root of 3, which is 1.732. So that's my second guess. Okay, so now that goes back in. So x3, well, x3 is the square root of 5 times x2, which is that, take 2, which if I stick that in my calculator, I will get 2.581. x4, well, x4 is the square root of 5 times x3, take 2, which is 3.302. x5 is the square root of 5 times x4, take 2, which is 3.809. Okay, so hopefully by now you've got the idea. Okay, now you can see actually that I've put 1 in because I know that my root is between 0 and 1, but actually it started looking like it's getting bigger and bigger and bigger. Okay, why is it moving away from the root? Right, well, what I want you to do, in the exam, you will not need to write all of this down. There is a quicker way for you to get all those numbers. So this is how you're going to get all your numbers. what you're going to do is you're going to type into your calculator 1, and then you're going to press equals. So if you do that now, and we're saying 1 because we're choosing x1 to be 1. So you type 1 into your calculator and then press equals. Okay, now what I want you to do is I want you to type the square root of 5 times answer, so answer button, take 2, and press equals. Okay, and that should give you 1.732. Then if you press equals again, it will give you 2.581. And then if you press equals again, it will give you 3.302. And then if you press equals again, it will give you 3.809. And you can just keep pressing. And if you keep pressing equals, you'll see that actually it starts to converge. And it starts getting closer and closer and closer to an answer. And you should find by now, because I've been talking for long enough, that you end up with, to 2 decimal places, you will end up with 4.56. Which, if you notice, is the other root. So not the one that I was hoping to find, but it's found the other one. Okay, now I did know that that was going to happen. Okay, now what's happening? So this iterative formula won't ever go to the one that's at 0.44. This particular iterative formula will always want to take me to 4.56. And to illustrate, we can illustrate this graphically on what we call a staircase diagram, and you do need to be able to draw these in an exam. So I'm just going to show you graphically what happens. Okay, so here the line is y equals x, and the curve is y equals root 5x minus 2. And you can see those are my 2 roots. There's one at 0.44 at the bottom here, and there's another one at 4.56. So where those points of intersection are the solutions to where the quadratic crosses the x-axis. Okay, so this links to what I was saying yesterday in terms of solving equations. So what's happening is that we are saying x equals 1, and we're substituting 1 into, for x, so this is x1 here, we are substituting 1 into the curve. And so this value here is 1.732. Okay, because you're substituting your 1 into root 5x minus 2. And you get 1.732. But if x is 1.732 here, if y is 1.732 here, then x is 1.732 here, because this is the line y equals x. So then what happens when you're here? Then you substitute 1.732 into the curve. So at this point here, y is equal to 2.581. But if y is 2.581 here, then it's also 2.581 here, but then so is x, because this is the line y equals x. So then what you do is you sub 2.581 into the curve, and at this point here it's 3.302, but y is 3.302 here, but then so is x. So then you're substituting 3.302 in to the curve, to get 3.809. That's 3.809. So then you're substituting that in. And all that happens is that that staircase, as you keep pressing equals on your calculator, it just converges and gets closer and closer and closer to that 4.56. Okay, so graphically you can see why that iterative formula wanted to converge to that particular root. Okay, let's have a look at another version. Okay, here is, go back, this one here. Okay, so this is the line y equals x, and we've now got the curve x squared plus 2 over 5. All right, okay, I'm going to say, this time, I know I've got a root in the interval 4, 5, so I'm going to say x1 equals 4. Okay, so if you type 4 into your calculator and press answer, or press equals, then if you type, so then you're going to type answer squared plus 2 over 5 into your calculator. So your calculator automatically inserts the previous answer. If you press equals, you'll get the second value, which is 3.6. And then if you press equals again, you'll get 2.992. And then if you press equals again, you'll get 2.109. And then you'll get 1.36. Okay, and again, if you keep pressing equals over and over and over and over again, you'll see it starts to converge, and you end up with x equals 0.44 to 2 decimal places. Okay, so this one, despite the fact I started near the other root, has converged to the one between 0 and 1. And I can show graphically. Okay, so here we started at 4. So this is my x1. So we substituted that into the curve. So at this point here, we're at 3.6. Okay, but at 3.6, y is also 3.6 there, but then so is x. So then we put 3.6 into the curve. And here we're at 2.92. But that's the same as the point on the line. So then we put 2.92 in. Now we're at 2.109. But that's the same as there. So then we put 2.109 in. And then we get to 1.36. And so on. So this one, as you can see, with a little staircase, converges to the other root. Okay. Now, there's no way of knowing when you find an iterative formula which root it's going to go to, okay, or even if it's going to completely miss, okay, but you don't need to worry about that in the exam. They will always give you the iterative formula, so you're never going to have to just come up with one yourself. You might have to show where it's came from by rearranging, but the question will give you the iterative formula, because otherwise the examiner could be marking all sorts of different solutions. So they will give you the iterative formula and they will give you your first value that you're going to substitute in. Okay, so your iterative formula will always converge to a root. Okay, but it's important that you understand that it doesn't always converge to the root. Sometimes you can find 4 iterative formulas and they'll all converge to the same roots and completely miss the other one. Okay, so it's a bit hit and miss, but in the exam they will give you the formula that they want you to use. Okay, so it's interesting. You do need to be able to draw this staircase diagram. So if you look what I did, I'll just go over it again. Okay, I went up to the curve. So vertically to the curve, horizontally to the line. Vertically to the curve, horizontally to the line. Vertically to the curve, horizontally to the line. And I did that with the other one. I went vertically to the curve, horizontally to the line, vertically to the curve, horizontally to the line, and so on. Okay, now there's one other option. So this is for a different equation, because I couldn't get the other equation to work for this to demonstrate. But let's say we wanted to solve that. Okay, we can rearrange that. If I, for example, so we've got an iterative formula there. If I start with that, if I move the 3 over and then factorise, if I then divide, I will end up with that iterative formula, that rearrangement. Okay, so that's where that came from. The reason why I've just chosen this is to just demonstrate, okay, so we can see that there is a root for that particular equation in the range or in the interval 1 to 2. Okay, so if we start with x1 equals 1, so if you type 1 into your calculator and press equals, and then type 3 over 1 plus log answer, and keep pressing equals, have a look what happens to the numbers. So keep pressing equals on repeat. So you should get x2 is 1.43, x3 is 2.21, x4 is 1.67, x5 is 1.98. And you should, if you keep pressing equals, you should find it converges to 1.85. But it converges in a different way this time. What's happening is it's jumping around. So it starts off at 1, it goes to 1.43, then it goes bigger, then it goes smaller, then it goes bigger, then it goes smaller, then it goes bigger. So it's constantly jumping from smaller to bigger, from smaller to bigger, but then getting closer and closer and closer. Now we can see that on a diagram. Okay, now this time the diagram is different. It's going to look like what we call a cobweb. So, but I'm going to do the same process. So I'm going to go, so from 1, that's where x1 is. I'm going to go vertically to the curve and then horizontally to the line. And then I'm going to go vertically to the curve, and then I'm going to go horizontally to the line, and then vertically to the curve and horizontally to the line, like that. Okay, I've just realised, I apologise, that these numbers might not be quite right. I think I started it at 3 by accident. So you might have slightly different numbers here than me, because I started at 3 for some reason on my calculator, but it should still have converged to 1.85. Okay, so your x1 up to the curve, along to the line, vertically to the curve, horizontally to the line, vertically to the curve. So you can see the spiral as it converges to that root at 1.85. So that's slightly different. So you've got a staircase, so it's you know it's going to be a staircase diagram if it converges from what I would consider to be the same direction. So it either gets smaller, 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 or bigger and bigger and bigger and bigger, and converges. You know it's going to be a cobweb diagram if it bounces around until it converges. Okay, that's the end of the second video. In the next video, we're going to be looking at some examples that involve the full process. So locating the root, using the iterative formula, and sort of proving that it's correct to the right decimal place.